From an $8 billion tunnel decades in the making to a railway that will finally unite the Balkans after decades of division, and from Paris building a metro system larger than London's in just 15 years to a canal that could literally split Turkey in half, Europe is home to some of the world's most ambitious construction megaprojects. Don't miss out as we dive deeper into these multi-billion creations reshaping a continent, starting with an engineering marvel crossing borders. Denmark has built some of the longest bridges and tunnels in the world, including the impressive Øresund Bridge. However, the link between the European mainland and Denmark still needs to be improved. Many people have to take a huge detour or take the ferry to cross the sea, which can be very time-consuming. Every hour, a ferry leaves the Danish island of Lolland carrying trucks, cars, and passengers across the Fehmarn Belt straight to Germany. The crossing takes 45 minutes, assuming the weather cooperates. For one of Europe's most important trade corridors, this 18-kilometer stretch of water has been an expensive headache for over a century. The Danes and Germans have been talking about building a bridge or tunnel here since the 1800s. Every few decades, someone would propose a solution, engineers would study it, politicians would argue about costs, and nothing would happen. The ferries kept running, the delays kept mounting, and everyone accepted that crossing between Scandinavia and continental Europe meant either taking a ferry or driving hours out of your way through northern Denmark. The conversation changed in the 1990s when the European Union started pushing for better connections between member states. Denmark had just completed the Great Belt Bridge, connecting the main Danish islands, and proved they could handle massive infrastructure projects. Germany wanted better access to Scandinavian markets. Both countries realized that trucks waiting for ferries were costing their economies millions in lost productivity every year. In 2008, Denmark and Germany signed a treaty. Denmark would finance and build the tunnel, operated as a toll crossing, and eventually recover the costs over several decades. Germany just had to build the connecting rail and road infrastructure on their side. After environmental reviews that took years and survived multiple legal challenges from groups worried about Baltic Sea ecosystems, construction began in 2021. Denmark is using the immersed tube method, building giant concrete tunnel segments on land, floating them out to sea, then sinking them into a trench on the seafloor. Each segment is 217 meters long and weighs 73,000 tons, roughly the weight of the Eiffel Tower. A purpose-built factory near the construction site churns out about 10 segments per year, assembling the rebar, pouring the concrete, and fitting out the interiors before the segment ever touches water. The installation process requires near-perfect weather. Tugboats tow each segment to the exact GPS coordinates where it needs to sit. Then workers carefully flood ballast tanks to lower it into the pre-dredged trench. The segment has to land within centimeters of its target position, because once it's on the sea floor, there's no easy way to move 73,000 tons of concrete. Divers and remotely operated vehicles then connect it to the previous segment, sealing the joints with massive rubber gaskets. Construction is further complicated by the Baltic Sea, with currents that push the segments off course. Weather windows for installation are short and unpredictable. The seabed varies from soft clay to hard glacial deposits, requiring different dredging techniques for different sections. In 2022, workers discovered unexploded World War II munitions in the construction area and had to halt work for weeks while bomb disposal teams cleared the route. The tunnel will actually be 2 separate tubes, one for road traffic with 2 lanes in each direction, and one for trains carrying both passengers and freight. A smaller service tunnel runs between them for maintenance access and emergency evacuation. The rail tunnel is designed for trains traveling up to 200 kilometers per hour, which means the journey from Denmark to Germany will take 7 minutes. The drive will take about 10 minutes compared to the current 45-minute ferry crossing that only runs when weather permits. The estimated cost of construction has also been altered a few times. Current estimates put the project's budget at $8.3 billion, which includes the improvement of the highway on the Danish side. The tunnel has been selected as one of the European Union's top infrastructure priorities, and it received the maximum support of 50% of the project costs and 30% of the advance activities. The rest of the project will be financed with government loans. They're planning to charge tolls high enough to recover the investment over 50 years. The Danish government is betting that time savings and reliability will make the tunnel attractive enough that people will accept the cost. The real value isn't just about shaving 35 minutes off a drive to Hamburg. The Fehmarn Belt completes a continuous road and rail link from Scandinavia through Germany and into the rest of Europe. Right now, freight from Stockholm to Munich has to account for ferry schedules and weather delays. After 2029, that same freight can move on a predictable timetable, 24 hours a day, regardless of Baltic storms. For logistics companies, that reliability is worth significant money. The rail connection matters even more for passengers. Copenhagen to Hamburg will become a direct high-speed rail journey of about 2.5 hours, compared to the current trip that requires either a ferry or a lengthy detour. That puts Copenhagen within comfortable commuting distance of northern Germany's major cities and ties Scandinavia into Europe's growing high-speed rail network. As of late 2024, about 50 of the 79 tunnel segments have been installed. The factory is running at full capacity. The installation crews have refined their procedures, and barring any major problems, the tunnel should open in 2029 as scheduled. Watching the construction progress is genuinely impressive. What was an empty seafloor 3 years ago now has a clear tunnel route visible in aerial photos as segment after segment gets positioned and connected. The environmental groups that fought the project for years are still monitoring construction, particularly the impact on harbor porpoises that migrate through the Fehmarn Belt. Denmark installed underwater noise barriers during pile driving, created artificial reefs to compensate for disturbed habitats, and hired marine biologists to track porpoise populations. Whether these mitigation measures actually work won't be clear until years after the tunnel opens. NATO doesn't talk about it publicly, but military planners love fixed links that can't be easily disrupted. Ferries can be blocked, delayed, or taken out of service. A tunnel 40 meters underwater is essentially immune to anything short of a major military operation. As tensions with Russia increase, having reliable ground transportation between Scandinavia and Central Europe has strategic value beyond civilian economics. In 2029, the ferry operators will lose most of their business. The Scandlines company that currently runs the crossing is already planning for this reality, reducing their fleet and shifting focus to other routes. The small towns on either side of the strait that built their economies around ferry traffic are facing uncertain futures. Some will adapt by becoming tunnel service stops. Others will fade as travelers no longer have reason to pause there. The Fehmarn Belt Tunnel won't be the longest tunnel in the world, or the deepest, or the most expensive, but it will be the longest immersed tube tunnel ever built, and it will fundamentally change how people and goods move through Northern Europe. Whether Denmark's $7.5 billion gamble pays off financially won't be clear for decades. What's already clear is that come 2029, the Baltic Sea stops being a barrier and becomes just another stretch of road you happen to drive underneath. While Denmark assembles their tunnel segment by segment beneath the Baltic, further south in the Alps, another tunnel has been taking shape through some of the hardest rock in Europe. The Brenner Pass sits at 1,370 meters elevation in the Alps, marking the border between Austria and Italy. For centuries, it's been one of the easiest ways to cross the mountains. The pass gets heavy snow, avalanches are common, and traffic frequently backs up for kilometers as trucks crawl over the mountain roads. In winter, the crossing can be genuinely dangerous. In summer, it's just miserably slow. Every year, more than 2 million trucks make this crossing, hauling goods between northern and southern Europe. Add in passenger vehicles and the occasional lost tourist, and you've got one of the busiest mountain crossings on the continent. The existing rail line through the pass, built in the 1860s, can't handle modern traffic volumes. Trains crawl at 50 kilometers per hour, and the steepness limits how much freight can be carried. The whole situation has been getting worse for decades as European trade increased. Austria and Italy started seriously discussing a solution in the 1980s. The obvious answer was a base tunnel, a long, flat tunnel drilled through the base of the mountains rather than going over them. This would allow high-speed trains and eliminate the elevation changes that slow everything down. The problem was the cost and complexity. The tunnel would need to be 64 kilometers long, making it one of the longest rail tunnels in the world, and it would pass through some of the most challenging geology in the Alps. The project officially started in 2007 after both countries secured EU funding and committed to their share of the estimated $10 billion cost. That estimate has since climbed past $12 billion and will probably go higher before construction finishes. Drilling began in 2011 from multiple access points on both sides of the border, with tunnel boring machines working simultaneously toward each other through solid rock. The geology has been absolutely brutal. The Alps aren't a uniform mountain range. They're a chaotic mess of different rock types that were shoved together and folded when Africa collided with Europe millions of years ago. The tunnel passes through zones of granite, gneiss, schist, and other metamorphic rocks, each with different properties that require different drilling techniques. Some sections are stable and allow fast progress. Other sections are fractured, water-saturated messes that constantly threaten to collapse. Water has been the biggest enemy. The tunnel boring machines keep hitting underground aquifers and water-bearing rock layers that flood the work areas. Pumps run constantly to keep the tunnel dry, removing thousands of liters per minute. In some sections, workers had to inject concrete into the rock ahead of the drill to seal the fractures before they could safely advance. This slows progress to a crawl and adds massive costs. The tunnel is actually two parallel tubes, each wide enough for a single train track, connected by cross passages every 333 meters for safety. If something goes wrong in one tube, passengers can evacuate through the nearest cross passage into the other tube. The excavated rock, over 18 million cubic meters of it, gets transported out and used for construction materials or dumped in designated disposal sites. Moving that much rock out of the tunnel without causing traffic chaos on the surface has been its own logistical nightmare. Progress happens through multiple construction sites simultaneously. Access tunnels drop down from the surface at several points, allowing crews to work on different sections of the main tunnel at the same time. This speeds up construction but requires precise coordination so that when the different sections meet, they're aligned to within a few centimeters. Getting that alignment right when you're drilling through unstable rock hundreds of meters underground is harder than it sounds. The original completion date was 2025. However, we are already beyond that. Current estimates put the opening somewhere around 2032, though nobody wants to commit to that publicly because every year seems to bring new delays. The Austrian and Italian governments keep insisting the tunnel will be finished soon, while the actual engineers quietly suggest it might take even longer. When it finally opens, the tunnel will transform Alpine transportation. Freight trains will be able to cross the Alps in 25 minutes at speeds up to 250 kilometers per hour, compared to the current 80-minute journey at crawling speeds. That's a huge improvement for logistics companies, and more importantly, it makes rail competitive with trucks for the first time. Right now, companies use trucks because they're faster despite being more expensive and worse for the environment. Fast rail through the Brenner-based tunnel could shift millions of tons of freight from roads to rails. Passenger service will see similar benefits. Munich to Verona becomes a comfortable high-speed rail journey of under 4 hours, compared to the current 6-hour slog that involves either driving over mountain passes or taking slow trains. Vienna to Venice drops to under 4 hours. Suddenly, crossing the Alps becomes as easy as crossing any other part of Europe, opening up tourism and business connections that currently don't make sense. The environmental argument for the tunnel is straightforward. Every freight train that uses it means dozens of trucks that don't have to drive over the Brenner Pass. That means less air pollution in the Alpine valleys, less noise, less road wear, and fewer accidents. Austria has been particularly aggressive about wanting to shift truck traffic to rail, imposing strict limits on how many trucks can cross the pass each day. The tunnel gives them a way to actually enforce those limits without strangling their economy. Despite the incredible engineering task, not everyone is excited about the tunnel. Local communities near the tunnel construction sites have had mixed reactions. The work brings jobs and economic activity, but also years of noise, vibration, and heavy truck traffic hauling materials in and excavated rock out. Some villages near the Austrian access tunnels have complained about cracked buildings from blasting and constant noise from construction equipment. The Italian side has seen similar issues. Compensation payments help, but they don't fully make up for years of disruption. The Brenner-based tunnel still represents a forward step for the environment. Freight can move efficiently without trucks clogging mountain roads. Passengers can travel sustainably at high speed. The problem is that building this infrastructure takes decades and costs billions, requiring political commitment that extends far beyond election cycles. Austria and Italy have maintained that commitment despite the delays and cost overruns, largely because the alternative, continuing to let truck traffic increase on the existing routes, isn't sustainable. The roads are at capacity, the pollution is getting worse, and every accident in the mountain passes causes massive traffic disruptions. The tunnel offers a way out of that trap, even if it's taking longer and costing more than anyone hoped. By the time the Brenner-based tunnel opens sometime in the 2030s, it will have been under construction for over 25 years. That's longer than it took to build most of Europe's great cathedrals. But unlike cathedrals, this tunnel will actually serve a clear, practical purpose, moving millions of tons of freight and millions of passengers through the Alps faster, safer, and cleaner than ever before. Whether that's worth $12 billion and counting is a question each taxpayer will have to answer for themselves. Speaking of alpine tunnels that took forever to build, there's one that's already operational and showing exactly what the Brenner Tunnel hopes to achieve. Switzerland finished something in 2016 that most countries would never attempt: a 57-kilometer tunnel straight through the Alps, the longest railway tunnel in the world. The Gotthard-based tunnel connects northern and southern Switzerland, cutting travel times and creating a flat, high-speed route where previously trains had to laboriously climb over mountain passes. The old Gotthard Railway, built in the 1880s, climbs and descends dramatically, with long spiral tunnels inside the mountain to gain and lose elevation gradually. It's a marvel of 19th century engineering, but slow and limited in capacity. The new base tunnel bypasses all of that, running flat and straight beneath the old route at depths up to 2,300 meters below the mountain peaks. The tunnel took 17 years to build, from 1999 to 2016, and cost about $12 billion. But the result is genuinely impressive. Trains now zip through the Alps at 250 kilometers per hour on a route that barely rises or falls at all. Building it required tunnel boring machines working from both ends plus multiple access points in the middle. The geology was similar to what the Brenner Tunnel is now encountering: fractured rock, underground water, unstable zones that required extensive reinforcement. Swiss engineers became experts at dealing with these problems, developing techniques that are now being used on other alpine tunnels. It wasn't all smooth sailing, as 9 workers died during construction, showing the kind of sacrifice required to drill through the mountains. The tunnel actually consists of 2 parallel single-track tubes with cross passages every 325 meters. This allows trains to run in both directions simultaneously while providing emergency evacuation routes. The ventilation system is powerful enough to handle a train fire, with massive fans that can reverse airflow and push smoke away from passengers. Since opening, the Gotthard-based tunnel has become the backbone of north-south freight transport through Europe. Goods moving from Rotterdam to Milan now travel through Switzerland faster and more efficiently than ever before. The tunnel shifted significant freight volumes from trucks to trains, exactly as intended. Swiss mountain valleys have less truck traffic and better air quality as a result. For passengers, the improvement is dramatic. Zurich to Milan dropped from 4 hours to under 3. The journey is smooth and comfortable, without the elevation changes that used to make the mountain crossing uncomfortable for some travelers. Tourism has increased as day trips that weren't previously feasible become easy. Switzerland invested heavily in connecting rail infrastructure as well. New high-speed lines leading to the tunnel entrances, upgraded stations, and improved schedules all work together to maximize the tunnel's utility. This comprehensive approach, not just building the tunnel but also ensuring everything connected to it works properly, is part of why the project succeeded. The Gotthard Tunnel shows what alpine-based tunnels can achieve when they're actually finished and operating. The Brenner tunnel will hopefully deliver similar benefits, and farther west, France and Italy are discussing a similar base tunnel under Mont Blanc. These projects take decades and cost billions, but they fundamentally change how people and goods move through Europe's biggest mountain barrier. While Europeans drill through the Alps, Turkey has been considering a project that would reshape their geography in a much more dramatic way. The Bosphorus is one of the world's busiest and most dangerous shipping lanes. About 43,000 vessels transit through it every year, navigating a narrow, winding waterway that passes through the middle of a city of 16 million people. The strait has sharp turns, strong currents, and heavy civilian boat traffic. Accidents happen regularly, including tanker collisions and groundings that have caused fires, oil spills, and deaths. Turkey can't restrict traffic through the Bosphorus because of the 1936 Montreux Convention, an international treaty that guarantees free passage for civilian vessels. The country can impose safety regulations, but can't charge transit fees or turn ships away. This has frustrated Turkish leaders for decades. Ships pass through their largest city, creating risk and congestion, and Turkey can't collect any revenue from it. Canal Istanbul would change that. President Recep Tayyip Erdogan wants to dig a canal across Istanbul, creating a new shipping route parallel to the Bosphorus Strait. He's been talking about this since 2011, calling it his crazy project, and promising it will transform Turkey's economy. The canal would be 45 kilometers long, connecting the Black Sea to the Sea of Marmara, effectively turning the western part of Istanbul into an island. The new canal would be entirely under Turkish sovereign control, allowing the government to charge whatever fees they want. Erdogan's government estimates the canal could generate billions in annual revenue while reducing Bosphorus traffic and the associated risks. The canal would be wider and straighter than the natural strait, making it safer for large vessels, particularly oil tankers coming from Black Sea ports. The plan calls for a 45-kilometer canal ranging from 275 to 360 meters wide and at least 21 meters deep, enough for the largest commercial ships to transit safely. It would run through the European side of Istanbul, starting near the Black Sea coast and ending at the Sea of Marmara's northern shore. 6 bridges would cross it, and a new city district would be built along its banks to house up to 1 million people. The estimated cost has varied wildly, depending on who's doing the estimating. Erdogan's government initially suggested $10 billion, then revised it to $15 billion, then stopped giving official estimates. Independent analysts put the real cost somewhere between $20 and $65 billion, depending on what gets included. The actual figure probably won't be known until, if, the project gets built and bills come due. Construction has never officially started despite years of announcements. Environmental impact assessments have been completed, route surveys done, and some preparatory land acquisitions made. But actual excavation hasn't begun, and it's increasingly unclear whether it ever will. The project faces 3 major obstacles: cost, politics, and geography. The cost problem is obvious. Turkey's economy has struggled in recent years with high inflation and a currency that keeps losing value. Spending tens of billions on a canal while the country faces more pressing infrastructure needs is hard to justify. The government would need to attract foreign investment or take on massive debt, neither of which has materialized. Politically, the canal has become toxic. Environmental groups oppose it because construction would destroy forests and wetlands, disrupt aquifers, and potentially trigger earthquakes in a seismically active region. Istanbul residents don't want their city literally split in two. Opposition parties have promised to cancel the project if they take power. International shipping companies have expressed skepticism about whether they'd actually use the canal given the fees Turkey plans to charge. The geography is problematic in ways that became more apparent as surveys progressed. The route passes through areas with active fault lines, raising concerns about earthquake vulnerability. The soil composition varies dramatically, including sections that are basically liquid in earthquake conditions. Building a canal that won't collapse or cause catastrophic landslides requires extremely expensive engineering solutions. There's also a fundamental question about whether the canal is needed. Yes, Bosphorus traffic is heavy, but it's not growing dramatically. Shipping companies are getting better at coordinating transits, and safety has improved despite the increased volume. Building a multi-billion-dollar canal to solve a problem that's gradually being addressed through better management seems questionable. The Montreux Convention creates another complication. International lawyers argue that if Turkey builds an alternative route and starts charging fees, other countries could challenge Turkey's right to continue regulating Bosphorus traffic under Montreux. This could backfire, forcing Turkey to allow unrestricted passage through both waterways without collecting any fees from either. That would be the worst possible outcome from Turkey's perspective. Erdogan continues to talk about Canal Istanbul in speeches, insisting it will be built and will be magnificent. But the rhetoric has become vaguer over time, with less emphasis on specific timelines and more focus on the visionary nature of the idea. Construction equipment hasn't appeared. Land acquisitions have slowed. The project exists in a strange limbo where it's never officially canceled, but also never actually starts. Most analysts now believe Canal Istanbul won't be built, at least not in the form currently proposed. The economics don't work, the politics are terrible, and the environmental and geological challenges keep getting more daunting as more detailed surveys are done. Turkey might eventually build a much smaller canal for specific purposes or develop alternative solutions to Bosphorus congestion. But the grand vision of reshaping Istanbul's geography seems increasingly unlikely. Canal Istanbul serves a political purpose regardless of whether it gets built, allowing leaders to appear bold and visionary. Whether anyone actually wants to execute the vision is almost beside the point. From Turkey's canal that might never happen, we head to Luxembourg, where a much smaller but actually progressing project is trying to transform how a tiny nation connects to Europe. Luxembourg faces a specific problem. It's tiny. The entire country covers just 2,586 square kilometers, smaller than Rhode Island, with a population under 700,000. Yet it punches far above its weight economically as a major financial center and home to numerous EU institutions. This creates constant pressure on limited land, particularly around Luxembourg Airport, which handles both passenger flights and massive amounts of cargo. The airport sits just a few kilometers from Luxembourg City, surrounded by industrial areas, highways, and not much room to expand. But expand it must. Cargo traffic has been growing steadily, passenger numbers keep increasing, and the airport's role as a European logistics hub becomes more important each year. The solution Luxembourg came up with is to basically build a new district on top of and around the airport. The Sky Park project aims to create a mixed-use development directly connected to the airport, with office space, logistics facilities, hotels, and even residential areas, all integrated into what's essentially a new neighborhood built around air transportation. It's urban planning designed for an economy where being close to rapid air cargo connections provides competitive advantage. The project started taking shape around 2015 when the airport and Luxembourg's government began seriously planning how to maximize the limited space available. Luxembourg couldn't sprawl outward like other countries. They don't have the space, so they decided to build upward and inward, creating density around existing infrastructure rather than expanding into new areas. One of the more interesting aspects is the actual Sky Park itself, an elevated park platform being built above ground-level facilities, creating usable green space in an area otherwise dominated by runways and warehouses. The park sits atop logistics buildings, accessible via walkways and stairs, providing recreational space for workers and residents without consuming valuable ground-level real estate. Below the park, warehouses and logistics centers connect directly to the cargo facilities. Companies can process shipments with minimal transportation between airport and warehouse, reducing costs and transit times. For businesses dealing in time-sensitive goods, pharmaceuticals, electronics, financial documents, this integration provides significant value. The development also includes Luxembourg's first major airport city concept, with hotels, conference centers, and office buildings designed specifically for business travelers who need quick airport access. Rather than building hotels in the city center and forcing travelers to commute to the airport, Luxembourg is building the hotels at the airport and creating an environment where short stays are convenient and efficient. Construction has been gradual and ongoing, with different phases completed at different times. The luxury hotel opened in 2019. Additional cargo facilities came online in 2020 and 2021. Office buildings are still under construction, and residential components are planned for later phases. The total investment is estimated around $1.5 billion. Modest by megaproject standards, but significant for a country Luxembourg's size. The residential component is particularly interesting. Luxembourg has severe housing shortages, with property prices among the highest in Europe. Building apartments near the airport, traditionally considered undesirable due to noise, requires careful design. The planned residential buildings will have extensive soundproofing, green spaces to buffer noise, and transportation connections that make living near the airport convenient rather than merely tolerable. Noise has been the biggest concern for nearby communities. Airport expansions typically face opposition from residents who don't want increased flight traffic overhead. Luxembourg has implemented strict noise abatement procedures, curfews on night flights, and invested in quieter aircraft to maintain neighborhood support. The trade-off is that these restrictions limit how much the airport can grow, forcing even more efficiency from the available infrastructure. The Sky Park project shows how small countries with limited space can still develop significant infrastructure by being creative with land use, building on top of existing facilities, and integrating multiple functions into single developments allows Luxembourg to expand capacity without consuming the open space they don't have. Cargo traffic has been the real winner. Luxembourg Airport has become one of Europe's major air freight hubs, handling more cargo than much larger airports in bigger countries. The tight integration between airport facilities and surrounding logistics centers makes Luxembourg attractive for companies that value speed and efficiency over pure scale. Whether the residential components will work remains to be seen. Living next to an airport, even a well-managed one, isn't most people's first choice. But Luxembourg's housing shortage is severe enough that apartments with good soundproofing and convenient transportation might find a market despite the location. The country has successfully marketed itself as a place where quality of life coexists with economic dynamism, and the Sky Park development needs to deliver on that promise. The project represents pragmatic urbanism rather than visionary grandeur. Luxembourg isn't trying to build the world's largest anything or reshape their geography. They're just trying to make the most of limited space by being clever about integration and density. Sometimes the most successful megaprojects are the ones with modest ambitions executed well. From Luxembourg's creative use of limited space, we head to Belgium, where Antwerp is trying to solve traffic problems that have plagued the city for decades. Antwerp has Europe's second-largest port and the traffic to prove it. Thousands of trucks move through the city daily, hauling cargo between the port and the rest of Europe. The problem is that Antwerp's ring road is incomplete. There's a massive gap on the northern side where the highway simply ends, forcing all that traffic through city streets or onto inadequate connector roads. It's been a bottleneck for over 40 years, and everyone agrees it needs to be fixed. They just can't agree on how. The Oosterweel link is Belgium's attempt to finally complete the ring road by building a combination of tunnels, bridges, and highways that would connect the two ends and create a complete loop around the city. The project would include a tunnel under the Scheldt River, new highway sections, and upgraded junctions to handle the increased capacity. When finished, through traffic could bypass the city entirely, reducing congestion in residential neighborhoods and improving air quality. The idea dates back to the 1970s, but serious planning didn't start until the 2000s. Initial designs called for a massive bridge across the Scheldt, which immediately drew opposition from local residents who didn't want a huge highway structure dominating their neighborhoods. Protests forced a redesign to include more tunneling, which increased costs significantly. Then, environmental groups objected to the project's impact on protected natural areas near the river. By 2010, the project was mired in legal challenges and political deadlock. Flanders, Belgium's northern region, which would fund most of the project, wanted it built quickly. Antwerp residents wanted more tunneling and less surface infrastructure. Environmental groups wanted it cancelled entirely. The Belgian federal government, which technically controlled parts of the route, added another layer of bureaucratic complexity. Everyone involved had veto power and nearly everyone used it. The breakthrough came in 2017 with the Oosterwelverbinding Agreement, a political compromise that satisfied enough parties to move forward. The new design included longer tunnels to minimize surface impact, additional sound barriers, and environmental compensation measures. The cost estimate climbed to over $5 billion, more than double earlier estimates, but at least construction could finally begin. Work started in 2018 on the first phase, involving preliminary infrastructure and preparation for the main tunnel excavation. The tunnel will be dug using two massive tunnel boring machines, each over 14 meters in diameter, drilling through the ground beneath the Scheldt River and Antwerp's northern suburbs. The excavated soil will be used for land reclamation projects and environmental restoration, turning a waste disposal problem into an opportunity to create new wetlands. The Scheldt Tunnel will be 1.8 kilometers long. Unlike many urban tunnels, which are just functional concrete tubes, the Oosterweel Tunnel will have design elements meant to reduce driver stress and improve safety. LED lighting will simulate daylight, walls will be less monotonous, and the tunnel will be wide enough to avoid feelings of claustrophobia. Above ground, the project includes new highway sections connecting to the tunnel, plus renovations to existing junctions that are already overcrowded. Some residential areas will see buildings demolished to make room for the wider roads, a politically sensitive issue that required extensive negotiations and compensation packages. Belgium's dense population means there's rarely empty space available for new infrastructure. Every project requires displacing someone or something. Current timelines put completion around 2030, though Belgian infrastructure projects have a history of delays. The country's complex political structure, with power split between federal, regional, and local governments, makes coordinating large projects difficult. Add in environmental reviews, legal challenges, and unexpected construction issues, and 2030 starts looking optimistic. The Port of Antwerp desperately needs this project. Every day that traffic crawls through city streets represents lost economic productivity and frustrated businesses. Shipping companies factor in the time it takes to move containers from port to highway when deciding which ports to use. If Antwerp's connections become too unreliable, cargo shifts to Rotterdam or Hamburg instead. The Oosterweel link is infrastructure the city needs to remain competitive. The Oosterweel link won't be celebrated as an architectural triumph or a technological marvel. It's utility infrastructure, necessary but not glamorous. Completing Antwerp's ring road solves a decades-old problem and allows the city to function more efficiently, but it's the kind of success that mainly gets noticed when it's absent. Belgium is betting $5 billion that fixing this bottleneck will pay for itself through improved traffic flow, economic growth, and better quality of life for residents who currently deal with constant through traffic. Whether that bet pays off depends partly on execution, but mostly on whether completing the ring road actually shifts as much traffic as predicted. Sometimes transportation projects change behavior in unexpected ways, with new capacity simply attracting more traffic rather than reducing congestion. Antwerp will find out soon enough. From Belgium's highway struggles, we head east to Serbia, where Belgrade is trying to build something it should have had decades ago. Belgrade is one of the largest European cities without a metro system, and the lack shows. Traffic is chaotic, buses are overcrowded, and there's no efficient way to move the city's 1.7 million residents around. Every major European capital has a metro except Belgrade, and the absence has become both an infrastructure problem and a matter of national pride. Serbia has been talking about building a Belgrade metro since the 1970s. Yugoslav-era plans included detailed designs, route surveys, and feasibility studies. Construction never started because Yugoslavia collapsed. Serbia went through wars and economic crisis, and there simply wasn't money for expensive metro systems. For decades, Belgrade Metro remained a dream that kept getting postponed. That finally changed in 2018 when Serbia secured Chinese financing and technical support to build the first metro line. The deal is part of China's Belt and Road Initiative, with Chinese companies providing most of the construction expertise and Chinese banks providing most of the $5 billion in loans. Serbia can't afford to build a metro with its own resources, so Chinese financing makes the project possible, even if it comes with significant debt obligations. The plan calls for 3 metro lines eventually, but only Line 1 is currently being built. The first phase will be 22 kilometers long with 21 stations, running from Belgrade's northern suburbs through the city center and south toward the airport. Construction began in 2021 with tunnel boring machines imported from China to handle the excavation. Building a metro in Belgrade presents unique challenges. The city sits at the confluence of 2 major rivers, the Sava and the Danube, with geology that varies from soft riverbed sediment to hard limestone. Some areas require deep excavation to reach stable rock for tunnel foundations. Other areas have high water tables that require constant pumping to keep work sites dry. And throughout the city, there are layers of archaeological remains from Belgrade's long history as a strategic river crossing. Every time excavation starts, archaeologists show up because there's a good chance of finding something historically significant. Belgrade has been continuously inhabited for thousands of years, with Roman ruins, medieval fortifications, and Ottoman-era structures layered beneath the modern city. Construction must pause whenever artifacts are discovered, adding delays and complications to an already complex project. The Chinese construction crews are using tunnel boring machines for most of the underground sections, but cut-and-cover construction is being used in some areas where the metro runs close to the surface. This involves digging a trench, building the tunnel, then covering it back up, disruptive to surface traffic, but faster and cheaper than deep boring. Entire streets are being torn up and rebuilt, causing traffic chaos that will last years. Serbia initially hoped Line 1 would open by 2027, but that timeline has already slipped. Current estimates suggest 2028 or 2029, and those dates might prove optimistic. The project has faced the usual challenges of complex urban construction, unexpected ground conditions, utility conflicts, and coordination problems between multiple contractors. The Chinese companies are learning that building metro systems in historic European cities isn't quite the same as building them in modern Chinese cities with simpler underground conditions. The financial arrangement has drawn criticism from economists worried about Serbia's ability to repay Chinese loans. The terms aren't particularly favorable, with interest rates higher than Serbia could get from European lenders if European lenders were willing to finance the project, which they largely aren't. Serbia is betting that the economic benefits of having a functioning metro will outweigh the debt burden, but it's not a risk-free calculation. For Belgrade residents, the construction disruption is worth it if the metro actually works. The city's bus system is overcrowded and slow, with no real rapid transit options. A functioning metro would transform urban mobility, making it practical to live in outer neighborhoods while working in the center. Property values along metro lines will increase, new development will follow the stations, and the city's overall economy should benefit from improved transportation efficiency. The metro also represents something symbolic for Serbia, proof that the country can build modern infrastructure despite decades of instability and economic problems. When Belgrade Metro finally opens, it will be a tangible sign of progress, a piece of infrastructure that puts the city on par with other European capitals. That psychological boost might be worth as much as the actual transportation benefits. Whether the metro becomes a financial success or a debt burden depends largely on ridership. If enough people use it to reduce bus subsidies and generate fare revenue, the investment makes sense. If it becomes an underutilized white elephant requiring ongoing subsidies, the Chinese loans will look like a terrible deal. Belgrade's future economic health rides partly on whether their first metro line can attract the riders it needs to justify its cost. From Belgrade's metro finally taking shape, we head west to a railway project that's trying to reconnect 2 countries with a complicated shared history. Hungary and Serbia share a border, major historical ties, and virtually no good rail connections. The existing railway between Budapest and Belgrade is ancient, slow, and barely used. The 350-kilometer journey takes about 8 hours on trains that rarely exceed 50 kilometers per hour, with the route winding through small towns and making countless stops. Most people drive or take buses because the train is too slow to be practical. This wasn't always the case. During the Austro-Hungarian Empire and later in Yugoslavia, the Budapest-Belgrade corridor was an important rail link connecting Central Europe to the Balkans. But decades of underinvestment left the infrastructure obsolete. Neither country had money to upgrade it, and for years after the Yugoslav wars, there wasn't much will to improve connections to a Serbia that was politically isolated. That started changing in the 2000s and 10s when both Hungary and Serbia began working with China on Belt and Road Initiative projects. China offered to finance and build a modern high-speed railway between the two capitals, cutting travel time from 8 hours to under 3. Hungary and Serbia would get modern infrastructure without having to finance it themselves, and China would gain another foothold in European transportation networks. The deal was signed in 2015, with Chinese companies contracted to upgrade the entire route to allow trains traveling at 200 kilometers per hour. The Hungarian section would be renovated and straightened where necessary. The Serbian section required more extensive work, including new track, new signaling, new stations, and electrification of lines that currently run on diesel. Construction started in 2017 on the Serbian side, where Chinese contractors began tearing up old track and laying new foundations. The Hungarian section faced delays because of EU regulations requiring public procurement processes for infrastructure projects, complicated by questions about whether the Chinese financing arrangements met European standards. Hungary eventually navigated these regulatory hurdles, but it took years longer than the Serbian section. The project has been controversial throughout. Critics in both countries question why China is so interested in building railways through the Balkans, suggesting the real goal is establishing strategic infrastructure control rather than economic development. The financing terms are opaque, with Chinese loans provided through state banks at interest rates and repayment conditions that aren't publicly disclosed. Some Hungarian opposition politicians called it a debt trap that would leave the country beholden to Chinese interests. Environmental groups have challenged sections of the route, particularly in Hungary, where the railway passes through protected natural areas. Delays from environmental reviews and legal challenges pushed timelines back repeatedly. In Serbia, construction faced fewer regulatory obstacles, but dealt with difficult terrain in some sections, requiring extensive earth-moving and bridge construction. The railway is being built to Chinese specifications, which differ from European standards in some respects. This created technical challenges in ensuring compatibility with existing Hungarian and Serbian rail networks. Locomotives and rolling stock will need to handle transitions between different systems, adding complexity and cost. Whether the promised 3-hour travel time can be achieved in practice depends partly on how smoothly these technical integrations work. Serbia has made steady progress on its section, with significant portions of track upgraded and new stations nearing completion. Hungary's section has been slower, with construction often paused for regulatory reviews or design changes. The two sections are supposed to meet at the border and provide seamless service, but coordinating the construction timelines has proven difficult. Questions have also swirled around the economics of the railway. Freight traffic between Hungary and Serbia isn't particularly heavy, and there's no obvious demand for a high-speed passenger rail connection. The route is primarily justified as part of a larger Chinese vision for rail freight from Chinese ports through Greece to Central Europe. But whether that freight traffic will materialize remains speculative. The railway might generate more cost than revenue for decades. Current estimates suggest the Hungarian section might be completed around 2025, with the Serbian section finishing around the same time. Whether both sections will actually be done and operational simultaneously is uncertain. Opening ceremonies might feature trains that technically can reach 200 kilometers per hour on some sections while still crawling through other areas, waiting for upgrades to be completed. The Budapest-Belgrade Railway represents Belt and Road infrastructure at its most visible in Europe. Chinese-financed projects that might or might not make economic sense, but definitely increase Chinese influence. For Hungary and Serbia, it's modern infrastructure they couldn't afford to build themselves. For China, it's another piece in a larger geopolitical strategy. Whether it benefits the people who actually live along the route depends on factors that won't be clear until the railway has been operating for years. From railways that connect countries to a metro system trying to connect a capital city better to itself, we head to France. Paris has a famous metro system, one of the oldest and busiest in the world. But there's a problem. It was designed over a century ago for a much smaller city, and it focuses almost entirely on moving people to and from the historic center. The suburbs, home to millions of residents, are poorly connected. Getting from one suburb to another often requires traveling through the congested city center, turning what should be a short trip into an hour-long ordeal. The Grand Paris Express is France's solution, a massive expansion that will add 200 kilometers of new metro lines, forming a network of orbital routes around Paris. These new lines won't just connect suburbs to the center. They'll connect suburbs to each other, creating a web of rapid transit that should transform how the entire metropolitan region functions. The project was announced in 2007, went through years of planning and debate, and finally began construction in 2016. It's the largest urban infrastructure project in Europe, with 4 new automated metro lines being built simultaneously. The total cost is estimated at $40 billion, though that figure keeps climbing as construction reveals complications. Building metro tunnels under an already crowded city is extraordinarily difficult. Paris's underground is a chaotic mess of existing metro tunnels, sewer systems, utility conduits, underground parking, building foundations, and archaeological remains. Every meter of the new tunnel has to navigate through this subterranean maze without disturbing existing infrastructure or collapsing historic buildings. Tunnel boring machines are working from dozens of access points simultaneously, drilling through the limestone and gypsum that underlies the Paris region. Some sections pass through old quarries that were excavated centuries ago and now exist as empty voids beneath the surface. These areas require extensive reinforcement before tunnel boring machines can safely pass through, adding time and cost to every meter of progress. The project includes 68 new stations, many in suburbs that have never had metro access. These aren't simple platforms. They're massive underground complexes with shopping areas, social spaces, and connections to bus networks. Some stations are being built 30 meters underground, requiring enormous excavations that take years to complete. The stations themselves are being designed by different architects, giving each one a unique identity rather than the cookie-cutter approach used in many metro systems. Archaeological discoveries have caused predictable delays. Roman ruins, medieval burial grounds, and remnants of old villages keep appearing whenever excavation starts. French law requires proper documentation and often preservation of significant finds, pausing construction until archaeologists finish their work. Some discoveries have been spectacular enough to warrant museums, further delaying the project but adding cultural value. The new lines are being built as fully automated systems, with no drivers and sophisticated sensors managing train movements. This allows for higher frequency service and lower operating costs. But it also means extensive testing is required before opening to ensure the automation works safely. Several planned opening dates have been pushed back because automated systems failed initial tests and required redesigns. Line 15, the Southern Orbital Line, was originally supposed to open in sections starting in 2022. That didn't happen. Current schedules suggest the first sections might open in 2025, with the complete line operational by 2030. Lines 16 and 17, serving the north and northeast suburbs, are following similar delayed timelines. Line 18, connecting to airports and southern suburbs, keeps getting pushed back as budget constraints force slower construction. The $40 billion price tag has French politicians arguing about priorities. Critics point out that $40 billion could fund massive improvements to existing infrastructure, new hospitals, schools, and social services. The suburban mayors who championed the project argue that decades of underinvestment in suburban infrastructure have created inequalities that the Grand Paris Express will finally address. The project's biggest impact will be on suburban employment patterns. Currently, many suburban residents work in the city center because commuting between suburbs is too difficult. Once the orbital lines are operational, jobs anywhere in the metropolitan region become accessible, potentially redistributing economic activity and reducing pressure on the historic center. Some suburbs that were previously considered too far from Paris to be desirable are being transformed by the promise of 30-minute commutes to the center. However, whether the Grand Paris Express delivers on its enormous cost remains to be seen. The London Crossrail project, which shared some similar goals, went vastly over budget and behind schedule while delivering less capacity than promised. Paris is trying to avoid those mistakes, but complex urban infrastructure projects have a way of exceeding expectations in the wrong direction. By 2030, if construction stays roughly on track, Paris will have a dramatically expanded metro system that finally connects its suburbs in rational ways. The impact on urban development, employment patterns, and quality of life could be transformative. Or the project could be a massively expensive system that doesn't attract enough riders to justify its cost. The answer will depend on factors from French economic health to pandemic-era remote work patterns to climate policies affecting transportation choices. The Grand Paris Express represents Europe's commitment to public transportation at a scale that seems almost inconceivable to Americans. $40 billion for metros and trains, while the United States struggles to build single transit lines for a fraction of that cost. Whether this European model is sustainable or a luxury that can only be afforded during periods of economic stability remains an open question. Which of these megaprojects did you find the most impressive? Do you think Europe's new tunnels can rival Switzerland's Gotthard tunnel? Comment your thoughts below. If you enjoyed this video, don't forget to see our compilation of the most insane megaprojects in the Middle East. And keep following SIGNUM for the stories behind the world's most ambitious construction plans.